Hello guys, welcome to the course and let's get into the next part of our course, that is doubly linked list and circular linked list. So at the very first, what is doubly linked list? A doubly linked list contains an extra pointer typically called previous pointer together with next pointer and data which are there in singly linked list. For example, children holding each other's hands like this. This is one example which I would like to explain you. So here you could see that this girl is linked with this boy and this boy also. Now this boy is also holding the hand of this girl and also the hand of this girl. It means that each person is linked with previous and the next person. Like this girl is linked with two guys and this guy is linked with two girls. Likewise only doubly linked list works. Doubly linked list has an extra pointer in it which is typically called previous pointer, and also it has one more pointer which is next pointer, as usual we were having in singly linked list. Now let's have a look on the node of doubly linked list, and this is how the node of doubly linked list look like. So doubly linked list is basically consists of three parts. One is the part which holds the address of previous node, that is previous pointer. This is the data part of the node, and this is the next part of the node which holds the address of next node. Let's compare this example with the doubly linked list and we will understand how this doubly linked list works actually. So let us assume that this first boy is the head of the doubly linked list. So now you could see that this girl is holding the hand of this boy and this boy too. That means that this girl is linked with two boys. Likewise, have a look on this node. So here this node is holding the address of this node also, that is the address of previous node also and the address of next node also. Like this girl holds the hands of both the boys. But look at this boy which is standing here, that is this one. This acts like a first node in the linked list. So what this boy is having, that this boy isn't holding the hand of anyone, that is you could consider it as a null part. So always remember that wherever the first node of linked list is present, at that time previous part of the node is always null. That is, previous pointer of the node will always be pointing to null. And likewise, this girl also works. You could see that this girl isn't having anyone's hand to be holding on. That's why next part of the last node is always null. So these are some points which you have to remember, that previous part of the start or head and next part of the tail or end is always null. As you can see, previous part of this boy is null and next part of this girl is null. But rest of the persons present over there, like these nodes are present here, works in the same manner. This girl is holding the hand of two boys and it is linked with the previous boy also and with the next boy also. Likewise, this 20, this node having the data part as 20 also works like this girl. It holds the address of previous pointer to and the next pointer to. So this is how the linked list, doubly linked list works like. It works like singly linked list only the extra point is that it is having a such kind of extra pointer which could hold the address of previous node also. Now let's dive into the code and we will see how the program for linked list is. Now in doubly linked list, as you know, there are two parts. One is the previous pointer and one is the next pointer. So previous pointer holds the address of the previous node and the next pointer holds the address of next node. So here in the structure of node, I have already defined that struct node asterisk next is one of the pointer which is holding the address of the next node. So I have to make changes here in the program that I have to do struct node asterisk previous. Let's take another pointer as previous, as in doubly linked list. This is one more pointer present over there. Now I have made struct node asterisk start equals to null. This is the same way like we have done in the singly linked list, only the change is after memory allocation, you know that we have to set the pointers to null. So you know that the next part is null, but also here the previous part will also be null. So one more change we have to make here, that is temp of previous will also point to null. Fine, so we set both the pointers to null. Now our temp is ready to get inserted into this doubly linked list, but we have to consider the three major situations. You could either insert this temp at the beginning or in the middle or at the end of the doubly linked list. So here is the program for inserting a temp into it. First, we have to check whether the linked list is empty or not, as like we have already checked it into the singly linked list. The whole program is similar, but there are few changes which we have to make into this doubly linked list program. So after dragging R, what we have to do is check whether the node, that is R of next, equals to null. What do it mean? That if the next part of the R equals to null, then for the sure it is the last node after which we are going to insert the temp, right? So if we are going to insert this temp at the end of the node, then what we have to do, what changes there are going to be held is the next part of the R, okay, I will write it into the code. The next part of the R equals to temp, right? That is the, suppose this is R. One second, I'll tell you. Suppose this is R, and after this we are going to insert this temp over there. So what changes are going to be held over there is that the next part of the R is holding the address of temp, and the previous part of the temp, what it is going to do, it is going to hold the address of the R, right? And this will be null only, right? Because this is temp is going to replace the last node, and it is playing the role of the last node in the doubly linked list at the moment, right? So now let's again get dive into the code. Right, here we were. Yeah, here we were. After that means R of next equals to temp, and temp of previous equals to R. Hope you got up to here. Now what we are going to do in the else part, if we don't want to insert the temp at the beginning or at the end, so what we have to do is we are going to insert this temp at the middle right now. We will consider the situation where we are going to insert this temp at the middle. Let me erase this so that you could understand it in a better way. So in the else part, right. So now in the else part, if push this at here. If this temp we are going to insert it between 20 and 30. So what will happen now? You know that this is R because we have already found R. This is R now. And this node we have to find. So how we will find this? You know that the next part of the R is the node which is getting disturbed after inserting temp into it, right? So what we will do here, I will take it above, right? So what we will do here, S equals to R of next. Why? Because right now I told you that, yeah, right now I told you that there is one more node which is getting disturbed when we are inserting temp into it. So we found one more, the first node which is getting disturbed, but we aren't able to find the second node. So what I am going to do is, the next part of the R is one node, the another node which is getting disturbed when we are inserting temp into it, and I am giving it name as S. This is the another node which is getting disturbed. Now let's again move to our code. So now temp is getting inserted here. So what will happen? The next part of the R will hold the address of temp, right? So I will write here, the next part of the temp will hold the address. Next part of the R will hold the address of temp, and next part of the temp will hold the address of S. And what will the previous part of S will hold? The previous part of the S will hold the address of temp, right? And this is how the insertion ends. What this code means, if you have got confused here, I will explain it in an easy way. When you insert temp here, so the next part of the R is going to hold the address of temp, right? This is what we have written here. Now, what will this temp will do? The previous part of temp will hold the address of R, right? And the next part of the temp will hold the address of S, whereas the previous part of S will hold the address of temp. That is only I have explained into this whole code, and hope you have understood this. So right now we deal with the insertion of the node. Now we are going to deal with the deletion of the node. So the whole program is actually similar to single linked list program. Only few changes we have to make here. So this is void del function which I have created for deletion of the node. So like in singly linked list also, we have first check whether the linked list is empty or not, for avoiding the condition where the underflow is happening, right? So likewise in doubly linked list also, we have to first check whether the linked list is empty or not, and then we have to perform deletion on it. If it seems that linked list is empty, then we will simply print a message that linked list is empty. But in else part, if it is found that linked list is not empty, then we will delete the nodes. So if it is found that temp equals to null, temp is the one node which we are going to delete. So for searching temp, what I have did is I again took one more variable which is info. Then I ask my user to input a value which he or she wants to delete. So I stored it into info. I compared the data part of temp with info, and I tried to find the node which we want to delete, which is temp. So here temp equals to temp of next. This dragging is done until the data part of temp isn't matching with info. When it matches with info, it exits the while condition and enters this if condition. If temp equals to null means if the node is the last node which we are going to delete, then which node is getting affected? This one, this previous node, the node which is having the data part 30. So how we will find this node which is getting affected? We will simply declare one more node, that is asterisk R, and then we will do that R equals to start, R of next does not equals to temp, and simply we will drag it until this while condition isn't getting false. So when we will find the R, that is the node which is getting affected, then we will stop there and that R will exit that loop, and then we will set that R of next equals to null, because this is the one changes we have to make after the deletion of the temp. Now you know that deletion of the node itself means that we are freeing up the pointers, and when we free up the pointers, you know that dangling pointers are created over there. So to avoid the dangling pointers, we are setting the temp of next equals to null. But wait, this is doubly linked list. Now we have to make changes over here. What we are going to do is, one part of node, that is next part, is getting to be is setting to be next, but another part also we have to set to the next, because the part which is previous part, it is also one pointer and we are also freeing up it, so we have to also make it null. So temp of previous equals to null. Now focus on this else part. If it is found that the node which we are going to delete is the starting one, is the first node, so what we are going to do is, if temp equals to start, printf percentage deleted, the similar message we have to do, we have to give that. Then start equals to start of next, right? We are dragging it, then we are making temp of next equals to null. But wait, we also have to again make here the temp of previous part as null. So to avoid the dangling pointers there, temp of previous equals to null. Fine. Fine up to this. Now again in the else part, if it is found that it is not the node at the beginning or at the end, but it is the node which we are going to delete, which stands at the middle of the linked list. So what we will do is, again we will perform the same steps which we have performed in the singly linked list. We will find the nodes which are getting affected. So first I find the node which is getting affected. The first node I named it as R, and the second node which is getting affected there is S. So let's say I want to delete this 30 from the node. This is my R which I find right now, and this is S. And how I found S? By doing simply R, while R of next does not equals to temp, drag S, and then I found S here, right? Now what are the changes which are going to happen here is that when you will delete this temp, right, when you will delete this temp, the next part of the R is going to S, right? This next part of the R will hold the address of S, and the previous part of the S will hold the address of R. This is the change which is going to be held there. And also, as we are freeing up this node, as we are deleting this node, means we are freeing up the memory of this node. So we have to set the previous part of the node to the null as well as the next part of the node to the null. So let's do these changes into it. Here we have to do the changes. One second, I have to select it. So after this, after dragging s equals to s of next, let me delete this. Yeah. What changes we are going to make here is that, one second, first enter R equals to R of next. First we will find the first node which is getting affected, then we will find the next node which is getting affected, that is temp. And what is temp? The next part of temp is S, and S is the second node which is getting disturbed over there. Then what will happen when we will delete temp? The next part of the R is assigned to the S, and the previous, and R will hold, once again, the previous part of the S equals to R. As we are freeing up the node, what will happen here? The previous part and the next part are set to null, right? So to avoid the dangling pointers, so I am doing it. temp of next will be null, and temp of previous will also be equals to null. So this is how the deletion works, and hope you got the deletion. Now let's have a look on circular linked list and we will discuss about it. So what is circular linked list actually? Circular linked list is a linked list where all nodes are connected to form a circle. Remember, there is no null at the end. A circular linked list can be singly linked list or doubly circular linked list. So have a look on this example where girls and boys are holding hand like in the previous example only, but here you could see that they have made a kind of structure like circle, and in the same manner the circular linked list works. So what will actually happen in circular linked list, you know that this node having data part 20 is holding the address of previous node also and address of next node also, right? But now have a look on this last one node, that is tail of the linked list, tail of the doubly linked list. You know that the next part of the last node is always null. Why? Because there is no node present in front of it so that whose address could be held into the next part of the node. So what we will do to form a circular linked list, this next part of the doubly linked list will hold the address of this node, the first node. Means the next part of the last node will hold the address of the first node, right? Hence, there will be no null at the end. There is no null part at the end of the linked list because this null part has been replaced by the address of the first node. Like this girl is holding the hand of this boy is holding the hand of this boy. Means they are linked in a circular manner and there is no hand which is not held by anyone, right? There is no hand which is not held by anyone. Everyone is holding hand of each other and forming a structure like circle. In the same manner, the circular linked list works. Circular linked list also have nodes which are connected to form a circle. And obviously, there is no null part present over at the end because that null part has been replaced with the address of the first node. Hope you got this. What is circular linked list? So hey guys, thank you so much. I'll see you in the next class.